You're not going to see a ton of these sequences series questions because we've done a lot of them already, right? So it looks like, there's just two summations going on here. But the first is arithmetic. Remember the formula for that? It's number of terms, which in this case is 24, divided by 2, times the first term, which is 8, plus the last term, which you plug in 24 and you get 54. And I know what that is? 744. 744? Thank you, ma'am. It's okay? Okay. The next one is geometric, and we're going to infinity, so we got to make sure, number one, r is between -1 and 1, right? A value that's going to make things smaller as you multiply, and because it's a half, that's going to work out for us. So the summation as we go to infinity approaches the first term, which in this case, remember, you always plug in this number here to find out what the first term is. Cool. And in this, it happens to be the 1/5 out front. It doesn't have to be that all the time. You plug in that bottom number first to see what the first term is, because this could start at like 3 for some reason. Okay? But either way, you plug in 1, you get a 5th, so that's the first term. Then you divide by 1 minus r, which is a half. Okay? And 1 minus a half is a half. A 5th divided by a half is 2/5. Cool? I know that's all review stuff. Hopefully that's... Mr. Flick made fun of me yesterday because I say cool all the time, so I'm sorry. I'm going to try to filter in new words. I say what? Yo. Yo. Okay. All right. How many distinct arrangements of a word? We did this. You count how many letters there are. How many letters do we have? 9. So that's how many ways we can arrange them. But then you've got to divide out how many ways we can repeat. So you got to count the repeats. There are 2 i's, right? So we're dividing by a 2. And it's really a factorial. That's just 2. There's 2 what? 2 i's, 2 n's. 2 g's. Is that it? 2 i's, 2 g's, 2 n's. Okay. So you're doing 9 factorial divided by 8, basically. I don't know what that is. 45,000 what? 360. Does everyone feel okay with those kinds of questions? Definitely see one of those. Okay. If there's 24 members in my class and I have 6 seats in the front, how many ways can I assign seats? Because the order matters, this is a permutation. Okay? And because I'm taking from a finite group and we're taking one out each time, we can use the permutation formula. Cool? So all you got to do is say there's 24. And we are trying to permutate 6 of them. Okay? And all that is, the math behind that is 24 times 23 times 22 times 21 till you get 6 things. Cool? It's a big number. I'm not going to write out what it is. Well, what is it? Let's just do it. What is it, Nat?
9690920.
Cool, so that is 96,909,120, which is a really big number. Okay. Miss Metzbauer, that's my wife, she likes to order pizzas, but she'll only order pizzas that have 4 or less toppings for some weird reason. Okay, so 4 or less. So she could have 4 or 3 or 2 or 1 or 0. Her favorite pizzeria has 6 different toppings. How many different pizzas could she get? Well, this is an or situation, right? If she's going to get 0 toppings, there's only one way she can do that, right? But really that is 6, choose 0. Or she could get 1 topping. Well, how many ways could she do that? 6, choose 1. We're doing choose here because it doesn't matter what order she chooses them because they're all in the pizza. Okay? Or she could get 2 toppings. Or she could get 3 toppings. Or she could get 4 toppings. Okay? So that's 1 plus, let's write this out. That's 1 plus 6. 6 choose 2 is 15. Plus 6 choose 3. Oh my god, what is that? 6, 5, 4. The 6 cancels though, so is it 20?
Yeah.
And 6 choose 4 is 15 again. Yo, I know 6 choose 4 is 15 because 6 choose 2 was 15. Okay? Anyway, what's that? 30, 57? Cool. Another way to do this, by the way, what row of Pascal's triangle are we adding up here? 6th row, right? So, and we know that Pascal's triangle, the whole row adds up to 2 to that power, right? So we could do that and then subtract off what we don't want. Well, she's not going to get a pizza with 6 toppings, and she's not going to get a pizza with 5 toppings. Is that okay? So you can do it that way as well, and you're still going to get 57. 2 to the 6th is 64. 6 choose 6 is 1, and 6 choose 5 is 6. So if you do it that way, you get 57 too. Is that okay? Okay. All right. We're creating a new committee that's going to have 4 seniors, 3 juniors, 2 sophomores, 2 freshmen. Okay? And the possible people that we can have in there, there's 7 seniors, 4 juniors, 4 sophomores, 3 freshmen. How many possible committees can we make? All you do is you take how many, so this is all an and. This is and, so we're going to multiply. Okay? This is an or. All right? Like the pizza thing was you could have 1 topping or 2 toppings. This is you need to have 4 seniors and 3 juniors. Okay? So you take how many ways you can do each thing and you multiply them. How many ways could I get 4 seniors? There's 7 of them, and we're choosing 4. And we need 4 juniors. 3 juniors, I'm sorry. 4 choose 3. And we need 2 sophomores. That's 4 choose 2. And we need 2 freshmen. That's 3 choose 2. Everybody okay with that? We're just multiplying all our options out. Cool. These aren't probability questions yet, so we're not dividing by anything. All right. I don't know what that's going to be. And for time's sake, I'm going to skip that. Does somebody have the answer? $25.20? Thank you, sir. Okay? No questions. Our expansion thing, if you remember, we got to go down to the 6th row of Pascal's triangle, okay? Which we actually just did on that pizza thing. We did all the 6 numbers pretty much the whole way across. Okay? Remember way up here? There's 1, 6, 15, 20, 15. And then 6, 1 would be the 6th row of Pascal's triangle. So let me write that out.
I can't see. Never mind.
Okay. It was 1, 6, 15, 20, 15, 6, 1. Okay? That's Pascal's triangle, the 6th row. You can add all the way down to that, or you can do 6 choose 0, 6 choose 1, 6 choose 2. Okay? But those are going to be the coefficients of this expansion. So, it's going to be 1 times that first thing to the 6th power, plus 6 times the first thing to the 5th power, times the second thing to the 1st power. Okay? And all we do is we use the coefficients, and the first thing goes up by, or goes down by 1 exponent, and the second one goes up by 1 exponent. So the next one's going to be 15 times 2a to the 4th times b squared plus 20 times 2a to the 3rd times b cubed. Let's shrink this up some. Everybody with me still? Can we finish this? 15 times 2a squared, b to the 4th. You can put that in parentheses, it doesn't matter for the b's. Plus 6 times 2a to the 1st, b to the 5th, plus 1, b to the 6th power. Is that okay? Yeah. We need 1. The first one? Because it's the first thing to the 6th, the second thing to the 0.
Oh.
Remember, the exponents always add up to the power you're at. So all the exponents have to add up to 6 in each term. Okay?
Oh, okay.
And look, we're not going to leave it like this, gang. I want you to expand it out. So 2a to the 6th, and you got a calculator, but 2 to the 6th is 64. A to the 6th plus 2 to the 5th is 32 times 6. What is that? 180, 192? Plus 2 to the 4th is 16 times 15 is 240. I don't know if anyone's checking these. If you're watching this video later on and I mess up at arithmetic thing, that's because I'm just trying to rush. But is it 240? Okay. Plus 2 cubed is 8 times 20. That's 160. A cubed, B cubed. Plus 2 squared is 4 times 15 is 60. A squared, B to the 4th. Plus 2 and 6 make 12A, B to the 5th. Plus B to the 6th. Whew. Is that okay? Yeah. Right here, is this 64? Because up here we're doing 2a to the 6th power. So it's 2 to the 6th, a to the 6th. Yeah. So all I'm doing here is going through, and the only thing you got to expand is the 2 to the power. So in every single term I got to raise 2 to whatever power it is, and then multiply it by the coefficient out front. Okay? Okay. Now, 2 says, what's the 10th term of this expansion? So we're going all the way out to the 20th. Okay? You don't go down to the 20th stupid row of Pascal's triangle. You just remember that each coefficient is a 20 choose something. Okay? And remember we talked about it, like you're always one behind. Like for instance, our first term up here, this coefficient here, was 6 choose 0. Okay? The second one was 6 choose 1. The third one was 6 choose 2. So, if we want to go out to the 10th term, we need 20 choose what? It's not 10. 9. You're always, it's 1 off. It's 9. It's always 1 less. Yeah. Okay. And because we're expanding x plus 5, you're going to have x to a power times 5 to a power, but you got to know what those powers are. Cool? And if you notice, look, let's just go back up to the 6 power thing here. This number right here, 20, was 6 choose 3. Okay? And the exponent on my second thing was a 3. This number here, 15, was 6 choose 4. And the exponent on the second term, or second factor there, was 4. This number here is 6 choose 5. This is a 5. Okay? So if I'm on 20 choose 9, the power on that 5 has to be
9.
A 9.
So x has to be 11.
And then x has to be 11 because the exponents have to add to 20.
Can you explain why 5 has a 9?
Yeah, man. So just going back up to the number 1 up here where we expanded out to the 6th, right? The powers of that thing were 20 choose, or 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, right? But for each time you're choosing like some value here, like 6 choose 0 was here, the exponent on b, the second piece, was 0. 6 choose 1 was here, b to the first. 6 choose 2 was here, b squared. So whatever you're choosing, whatever you choose, that number is, that's the same as the power of the second thing. So the fact that I did 20 choose 9 means 5 has to be raised to the 9th power. All right? Like so, like let's say I wanted the 15th term of this. The 15th term then would have to be 20 choose 14, always 1 less, and that means the exponent on b is 14, and the exponent on x would have to be 6, because they have to add the 20. Okay? I know, right? Okay, I'm going to erase that, though, because that's not part of our key. Okay. 25 choose 11 is the same as 25 choose... No. Well, yeah, you can't use 11 again. You got to use a different number. You're right. Technically, mathematically, 11 is an answer. But 14, they got to add to the same number. Or they got to add to 25, I mean. 14. Huh? Because, look, let's take a look at Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay? Look at this. So this is the 4th row, right? This is 4 choose 1. And over here is 4 choose 3. Okay? They always repeat. So as long as you're the same distance away from the ends, like you're going to get the same number on that row. Okay? And to guarantee you're the same distance, just this number here and this number here have to add up to whatever row you're on, which is the 4th row. In this case, So if you want 25 choose 11 to equal something, that's the 11th one, then you got to be 11 away from the other side, but just make it add up to 25, 14. Let's do it. And look, you can expand out that triangle if you want. Okay, but look, let's do another one. 100 choose 21 is the same as 100 choose 79. Okay? Because again, the Pascal triangle just repeats itself the whole way across. Because they have to add to whatever you're choosing out of. And look, we said another way to think about that, kids, 25 choose 11 means there are 25 things there, and you're choosing 11 of them to take. Okay? Which means if you choose 11 of them to take, how many are you leaving behind? 14. If you choose 11 out of 25, there's 14 left behind. So choosing 11 to take is the same exact thing as taking or choosing 14 to not take. Okay? That's why they're the same thing too. Okay. Let's do some probability. If you flip a coin 9 times, what's the probability you get 6 heads? Yo, in these probabilities here, you got to worry about like the situation we're in. This is, we're doing 9 things, and the probability of getting what I want is always a half. This is a binomial thing. Well, it's a half, which is the probability of getting what I want 6 times, right? And then a half, they happen to be the same because they're halves, of what I don't want 3 times, right? Heads 6 times, tails 3 times. But you've got to multiply by how many different ways can you arrange 6 heads and 9 flips. Well, that's 9. Choose 6 out front. If you don't multiply by it, then you're only finding the probability that you get exactly 6 heads in a row and then 3 tails. Which isn't what it said. It said 6 heads in any of the 9 flips. So you multiply by how many ways could I move those 6 heads around in those 9 flips. You have 6 spots to choose out of 9.
You have to multiply all those 3 together.
You multiply all 3 of those together. You're going to get some number. I don't know what it is, but okay. So on the test, you should, be spitting out a number here. Anybody know what this is? 0.164. Okay, which means there's about a 16% chance, 16.5% chance, like 16.4%, whatever, that you get 6 heads and 3 tails in 9 flips. Okay. All right. If you roll the dice 7 times, now this is an at least one question. Okay? If you want at least one, this is an or situation. You could do getting 1 or 2 or 3 or 4 all the way up to 7. Or you could subtract off the only thing you don't want, which is we don't want 0 5s, right? Well, the probability of getting 0 5s is 5 6. That's not getting a 5. The probability of getting of not a 5 is 5 6. And that's going to happen 7 times. We don't want that to happen, so we do 1 minus that. And that leaves all the possibilities of us getting at least one of them. Yeah, you like that?
That wasn't that one bullshit, right? You said if it's at least
Yep.
1, you subtract.
Yeah, if you see at least 1, yep. If you saw at least 2, then you could do 1 minus 0 minus 1. You know what I mean? You subtract, so you can either subtract off what you don't want from 1, but you can add up all the stuff you do want. So again, what we do want is 1 or 2 or 3 or 4 or 5 or 6 or 7. Well, you could either add all those up, or you could just do 1 minus 0. Okay? What's up?
Where did you get this 6 when you put the 5 over 6?
Because we're rolling a die, and the probability of us not getting a 5 is 5. There's 5 things that aren't 5s, 5 out of 6. Okay? The probability of rolling 2 dice that add to 7, we know there are 36 possibilities, right? So it's going to be out of 36. We've got to find all the ways we can add it to 7. So this isn't really like a calculating all out. You've got to think of all the ways we can add 7. So that's 1 and 6, which means also 6 and 1. 2 and 5, which also means 5 and 2. 3 and 4, which also means 4 and 3. And that's it. Is that okay? So there are 6 of them, right, out of 36, which is really 1/6. Okay? We did this on a little quiz we took before. 7 choose 3 means you're making 3 choices and you have 7 decisions for the first one. Okay? So you do 7 times, how many options do you have for your second choice? 6, because you've taken one out, and then 5. But that math there takes into account that different orders are different things. Okay? So we have to divide out all the repeats. So we divide out how many ways can I rearrange 3 things? 3 factorial. And this equals 35.
And 3 factorial is the same thing as doing 3 times 2 times 1.
That's exactly what 3 factorial is. Yeah, what's up?
I have a question about number 2.
Yeah.
So would you just leave it like that, or do you have to actually answer it?
Oh, you should tell me what this equals, man. Yeah, all of these gangs should have like decimal answers.
Okay.
I'm just kind of breezing through them. And I'm assuming you can do this on a calculator. Okay?
We need 5, 6, and 7. It's like 1.7861.
5, 6 to the 7. Oh, e to what? The what? Okay, so look. Let's do it. It's 1 minus, it's point what? 1 point?
7, 8.
I know.
5, 4,
178 what?
6, 1, 2.
Oh yeah, but e to what? 5. So you're going to move that decimal 5 places. So that's going to look like 1, 2, 3, 4, like that. It was between the 1 and the 7, right? 1.7. You move it 5 times to the left, because that means the number's small. That's what e negative 5 means. It means 10 times e to negative 5. Cool. That's just scientific notation. That's what that means, yeah. And 1 minus that is going to give you a number that's super duper close to 1. Okay? So basically what that says is if you're going to roll a die 7 times, the probability you see a 5 at least 1 time is very high. Okay? Like almost 100%. Okay. That seems, if you roll a die 7 times, you're probably getting at least 1 5. Yeah, okay. All right. In a deck of cards, let's do this. You're going to get 4 cards. Cool? What's the probability you get 4 spades? We can do these multiple ways. I'm going to do the combination way, which works in this case because we're drawing out and the numbers are decreasing as we take them out. Okay? So the probability of us getting 4 spades, well, how many ways can we get 4 spades? There's 13 of them, and we want 4. And we're dividing that by how many different hands could we get? 52 choose 4.
Oh, this is like the other question.
Okay. Can we handle that?
So we're talking about how many like cards.
There's 13 of each suit, yeah. And look, yeah, if you have a card question, you're like, yo, I'm not sure. Just I'll tell you the card information. I'm not going to like withhold card stuff. There's 4 suits of 13 each. Yep. Hearts, diamonds, spades. Oh my gosh, clubs. Yeah, thank you. Okay. Yeah, we could also do this with multiplication by multiplying by what we want. Okay. The probability of getting 4 spades. What's the probability you get your first spade on your first pick? How many of them are there? 13 of them out of 52. Look, you don't have to do both of these, but they're both the same number, okay? Either one of these will give you the answer. I'm saying they're equal, but you can do either one. What's the probability you get a spade on your second pick? And then 11 out of 50. And then 10 out of 49. The only thing you got to worry about is, like, are there multiple ways for this to happen? Like, can I rearrange how I get them? Well, no. In this case, no, because you're getting spade, 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 spade. There's only one way to get all 4 spades. They're all spades. Okay? No. In this case, you're done. Like, you'd multiply it by 4, choose 4. Because you want them all to be spades. And that's a 1. Okay? The probability of getting 4 kings is much smaller. Okay, and again, we want to know what these equal. These are going to be decimal numbers, okay?
Wait, so those two are like the same?
They're the same. Yeah, it doesn't matter which one of those you do. You're going to get the same answer. Okay? The probability of getting 4 kings, we can do the same thing. There's, how many kings are there? 4, and we want to get all 4 of them. So there's only one way that can happen. Yeah, divide it by 52. Choose 4.
Why isn't it 13 choose 4?
Because there's only 4 kings.
What if we don't know?
Oh, spades.
There's 4 of each card. There's 13 of each. Just ask me, okay? All right. Later on, when we start doing our card counting business, and we start, hustling all the casinos around here, you guys will be good at this. Okay, it's good. Okay. Yeah.
It's really hard,
And I'm fired. So, 4 kings also, gang, by the way, is the first king. You have a probability 4 out of 52, and then 3 out of 51, and then 2 out of 50, and then 1 out of 49. Again, you don't do both of these. Either one of them is fine, but they are equal. Yes, sir. Because there's 4 kings, and we need all 4 of them. So the only way for us to get that hand is king, 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 king. Whereas in the other one, there's 13 spades, and we need 4 of them. How many ways can that happen? 13, choose 4. Okay? 2 hearts and 2 clubs. So now this is an and, so we're going to multiply on top. How many hearts are there total? 13 of them, right? And we want 2. And we want 2 out of 13 clubs. Over 52. Choose 4. Because we're choosing 4. Like that's how many hands. So every single one of these, probability-wise, has to be over 4. Okay? What's up? The multiplication way would be, there's 13 out of 52, and then 12 out of 51, and then, no, times 13 out of 50.
So you would have had
Oh. Not 49. God dang it. 12 out of 49. You're multiplying because they're ands. We need a heart and a heart and a club and a club.
So what is the situation when you're adding?
They're or situations. Okay? But now look, so this right here says heart, heart, club, club. But it doesn't matter what order they happen in, so I need to multiply this by, we have 4 spots, and I'm choosing 2 of them to be those hearts. And then the other remaining 2 are just the clubs, whatever's left over. Is that okay? Okay. So this is 0.022. Great. What's the probability of getting no clubs? Well, the cards that aren't clubs, there's 39 of them, because 13 are clubs. So we need 39 cards, and we want to choose 4 of them. And we want to divide that by 52, choose 4. Okay? And look, I'm not sneaky at all about these at least questions, kids. I asked you at least 1 club, because I just made you find the probability of getting no clubs. So at least 1 club is 1 minus no clubs. It's just 1 minus whatever 39, let's just do that real quick. 39 choose 4 is a big number, divided by 52 choose 4 is 0.3038. Cool?
And for that, you just use 39. For the multiplication, you just use 39.
Yeah. Oh. So it's 0.696. Okay? And 2 hearts, 1 spade, and 1 club. This is an and question. Yes. So 2 hearts, we want 13, choose 2. 1 spade, 13, choose 1. And 1 club, 13, choose 1. All over. Oh, yeah, 4, not 3. Is everyone in this room feeling confident doing these kinds of questions? Again, the conditions for this to work out like this are, you have to be drawing from something without replacing it, and you have to be drawing from the same set each time. Because the next questions are about drawing marbles from bags, but they're different bags. So this technique is not going to work. Okay? Because we're not drawing from the same set. Okay. The multiplication method will always work. Alright? So you can do that for this too. Like, again, here, like, we could have easily done, check this out. This is the same thing. 2 hearts. The probability of getting that is 13 out of 52 times 12 out of 51. And then 1 spade. is 13 out of 50, and then 1 club is 13 out of 49. Is that all right for that question? But so the problem with doing it this way is you got to multiply by how many ways can I get this to happen. All right? So how many ways, look, we're really rearranging here 2 hearts, a spade, and a club, right? So what do I need to choose initially? Am I with me? Of my 4 cards, how many do I have to choose? 2 to be hearts, so we got to do 4 choose 2. But then after I choose those 2, how many spots do I have left? 2. There's 2 spots, and I have to choose one of those to be a spade. Okay, this is and. I need 2 of the 4 to be hearts, and of the 2 remaining, I need 1 to be a spade, and technically, of the 1 remaining, I need 1 to be whatever, a club. But 1 choose 1 is just 1. That's why, right? Like once you choose the first 3, the other one's just automatic. All right, so that's why that's not there. And if we go back up to C, 2 hearts and 2 clubs, the reason why it's just a 4 choose 2 out here is because once you choose the 2 hearts, then the 2 clubs are automatic. You don't get to pick which ones they are. They just happen to be where they are. What are you doing over there? How are kids on their cell phones right now? What's going on? Okay. We're choosing 4 different marbles from 1 bag each, right? You're going to pick 1 marble from each bag. Probably get a green. So this, we can't do the combination thing because we're not withdrawing from the same set each time. So we can just multiply them. So green, what's probably getting green in general? 4 out of what is this? 11. So it's 4 out of 11 times 4 out of 11 times 4 out of 11 times 4 out of 11. Let's do the 4th power. Because you're choosing 4 of them, and they each have 4 out of 11 chance of happening. Okay? And we don't need to rearrange them. It's just 4 out of 11, 4 out of 11, 4 out of 11. Okay? 3 red marbles, however, is 3 out of 11 to the 3rd, right? 3 out of 11 times 3 out of 11 times 3 out of 11 times, one of them's not red, 8 out of 11. So it's red, red, red. There's 3 out of 11 in each bag. That's the probability of getting a red. And then the probability of getting not a red is 8 out of 11.
You put that to the 3rd power.
No, because we're only doing 1 not red marble.
Why would it be 3 to 11 to the 4th?
Because we're only getting 3 red marbles. Okay, so this is confusing to people. Look, it's a red marble, and a red marble, and a red marble, and a not red marble. Yeah, but this right here says red, 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 not red. But it doesn't have to happen in that order. How many spots are we choosing to be red? 3 out of 4. Or you could choose 1 to be not red. 4 choose 1. Same number. Yes, and you're going to get an answer. What's up?
So you're doing one
Look at you now.
that's not red because you have to choose 4.
Yeah, and there's 3 red marbles, and then 1's not red. What's up now?
How is A and B different?
A is just 4 green. So it's 4 out of 11, 4 out of 11, 4 out of 11, 4 out of 11. We're just multiplying the probability of each thing happening. Yo, 1 red and 3 green, what's probably getting a red? 3 out of 11, and then a green. 4 out of 11, 4 out of 11, 4 out of 11. But then we're choosing 1 to be red or 3 to be green, whichever one you want. Same thing.
So, just for the last one real quick, would you just do 4 to 1 to 4 or 1? I don't know.
D?
You could do
Yeah, so 2 red marbles is 3 out of 11.
and then both.
Yeah, 4 out of 11. And how many blues are there? 2? So you're choosing 2 to be red. And out of the 2 that are left, you're choosing 1. Okay? All right. Yeah, we just finished, what did we do? 6D. So now we're on 7. Okay?
It's the same thing. You have to just find the.
Oh, yeah, it's right there.
Do the 4 choose.
Yeah, 2 red is 3 out of 11, 3 out of 11. A green is 4 out of 11. And a blue then is 2 out of 11. But you got to multiply by how many ways you can arrange those. So of the 4 spots, 2 have to be red. That's this. And then there's 2 spots left, and you have to pick one of them to be blue or red or green. And then there's 1 spot left, so it's really a 1 choose 1. But that's just 1, so you don't want to put that there. Okay? Okay. So, 7 is absolutely, most definitely, please tell me you can see this, a Venn diagram question. Because I'm telling you the intersection, how many are in the middle. All right? So we have band and we have chorus. Okay? And all we want to do is draw this Venn diagram. Can I zoom in on this? Oh yeah, let's make this big. Okay, here we go. Boom. Boom. So we have band, we have band and chorus. And what percent are in both? No, 25 are in both. So in here, oh no, things are bad. It's my jam. Okay, it's 0.25. And because 50% are in the band, that means over here also has to be, so I see this is not working, 0.25. And 30% are in the chorus, which means over here has to be 0.05. Do we all feel okay with those numbers? Okay, that makes up a total of 55% of my class, or calculus kids. Cool? Which means that there are 45% of kids that are not in either of those things. Okay? So, what 30%? We use that to find the chorus circle. The chorus circle has to have 30% in it, but the middle is already 25%, so outside of that is only 5%. Okay? 0.05? Because 25% are in both, and 30% are in chorus total. So if 25% are in that middle thing, there's only 5% left to be in the chorus circle. Okay? Now, what matters for these questions, okay, is what our denominator is going to be here. So for instance, this says if a student, just in general, is chosen at random, versus question B, if a chorus student is chosen at random. It changes the group you're looking at. Okay? So for A, I'm just looking at the students in my entire class. I want to know what's the probability they're not in chorus or the band. Well, what number is that? 0.45, and we're technically dividing that by 1, the whole group. Okay, so just 0.45, but really what's happening is you're dividing that by 1, because you're looking at all the students, which make up 100% of them. But down the bottom, if a chorus student is chosen at random, so now we're only looking at the chorus students. Well, what percent do they make up? Chorus students make up 30. So our denominator is 30.3. Because we're only looking at that subsection. Okay? What's the probability they're not in band? Well, what percent of kids are in chorus but not band? 0.05 goes up there. Okay? And what is that? 5 out of 30? That's a sixth. That's like 16.16667, we'll say. Cool? Oh, I gotta stop saying cool. Okay. Alright, so Venn diagram question, definitely. And once you know one's a Venn diagram question, I mean, I'm going to give you a tree diagram question, so that's what the next one's going to be. But you know it's a tree diagram question because I'm giving you a percentage for something 2 times. 25% have garages and 30% have garages. When you see a percentage like that pop up twice, that means it's coming off of a branch. Like there's 2 branches and that's coming off of each one. Okay? So this is definitely a tree diagram question, and we're going to have 2 branches initially. Those branches have to be the percentage I only gave you 1 time. Pools. So either a person has a pool or they don't have a pool. Man. Okay? The probability they have a pool is 45, so the probability they don't have a pool is 55. And then off of the having a pool branch, of those that have a pool, 25% have a garage. So you can either have a garage or you can have not a garage. Well, 25% have a garage, which means 75% of those people who have pools do not have a garage. And then you have 2 branches down here too. Okay? And this is garage and not a garage as well. Like the second branches are always the same labels. What's up, Jasmine? Come on in. So we have a garage or not a garage down here, but the numbers are different. 30% of these people have a garage. So 0.3 have a garage, which means 0.7 don't. Is everybody with me? And to get the numbers at the end, you multiply the branches out. So, 0.45 times 0.25, I don't know what that is. Help me out here. What's 45? 9 out of 20 times a fourth, 9 out of 80. Just multiply that out for me. 0.45. Point what? Cool. And 0.45 and 0.75? It's 27 out of 80. What's that? 33?
Yeah.
75. Cool. And 0.55 times 0.3? 165. So 0.55 times 0.7? 0.385? Okay. And all we just did here is broke our population into 4 groups. Those with a pool and a garage, those with a pool and not a garage, those without a pool and a garage, those without a pool and not a garage. There's 4 groups we have now, which is what we had up here really. There's 4 groups. You're either in band, you're in band and chorus, you're in chorus, or you're not in either. So those numbers at the end of this tree diagram are the same as the ones in the Venn diagram. We just get them from a different method because we have different information. By the way, what's the probability someone has a garage? Well, all you do is you go through and look at all the groups that have a garage. Okay? Just like we did up here in this circle. Like, what's the probability someone's in band? 50%. You add up to 0.25 and 0.25, right? The whole band circle makes up 50%. If we were to put these in circles, the whole garage circle will be made up of this and this. So the probability that someone has a garage,
You just add those two together.
that's it. Just like you did in the Venn diagram.
0.2775.
Yeah, my thing is messed up. 0.275? 2775.
Oh, so you don't have to put it over anything.
Well, so because look, again, it says if a neighbor is chosen at random, which means I'm looking at all my neighbors.
Oh,
So it's divided by one whole, the whole group. Okay? But the other one says, hey, let's just say if a neighbor has a garage, now I'm only looking at the percentage of people that have garages, which means my denominator is 0.2775. Okay? Because we're limiting the group we're looking at. What's the probability they have a pool? Well, what group of people have a pool and a garage?
1125.
There you go.
This video's on campus, right?
Well, it will be. Yep. Okay. Anybody know what that happens to be? .405. Okay.